Hello everyone. Today I am going to show you how to build the logistic regression model using TensorFlow and Spiner IDE, that is Python 3.6. I have used Spiner IDE as my platform to build the machine learning models. So, I am building the logistic model in order to classify the different species of flowers with respect to their measurements, and predicting the results of the test data, and estimating the accuracy of the model. What is logistic regression? Logistic regression is another technique borrowed by machine learning, which is a go-to method for binary or more classification problems. Logistic regression is named for the function used at the core of the method, the logistic function. Logistic regression uses an equation as the representation, very much like linear regression. A key difference from linear regression is that the output value being modeled is a binary values, 0 or 1, rather than a numeric value. To complete this process we need to have some prerequisites. They are JDK, Spiner IDE, Python version 3.6, 64-bit version, TensorFlow packages. The initial step starts with importing the packages that are required for building the code. I have used matplotlib library for plotting the graphs, NumPy to build arrays, TensorFlow for building the model using tensors. So, I am importing the dataset by name, iris, from the library, sklearn, where you can see the data and its attributes. This is the iris dataset, with images of the species of flowers, and the relevant data parameters. To import the data, create a variable by name iris, and call the dataset from sklearn, by using datasets.load_iris. Classify the data into features and labels, where label is the target variable, which is used for the prediction, based on the feature variables. Features data is stored in the object, x_vals, and labeled data is stored in the object, y_vals. Since the model we are building is a supervised model, we are splitting the data into train set and test set. The model is built using the train set data, and further the model performance is tested based on the test data. So, 80% of the data is assigned to the train set and 20% is assigned to the test set. For each train set and test set, the featured data and labeled data is taken separately into the objects like x_vals_train, x_vals_test, y_vals_train, y_vals_test for using them in further computations. Normalize the features data to improve the linearity level of the data, since it works effectively with logistic model. Now, create the placeholders and variables, and set up the learning rate of the model, and batch size, through which the computations of prediction occurs. So, the learning is set to be 0.05, and batch size is 25. Next, create a session object, which encapsulates the environment, in which all the operations are executed and tensor objects are evaluated, and graphs can be launched. So, the ses is the object we have created and call the object by using the function tf.session. Now initiate the model building process by building the logistic functions for data computations. First, linear function is created as tf.add, tf.matmul, x_data, a, b, and assigned to the object model_output. Here the variables a, b are the slope and intercept values of the linear function. Next, build a loss function which estimates the error value between the predicted and actual measurement, and it is written as loss equals tf.nn.l2_loss, model_output minus y_target, which is defined as squared error cost. Next, in order to optimize the error value on the given trained data, gradient descent optimizer function is used, which takes the error value and adjusts the predicted values with respect to the variables a, b, and finally minimizes the error rate. Now, we apply logarithmic or sigmoid function to the prediction output, to estimate the prediction values based on the probability level of acceptance, and it is written as prediction equals tf.round, tf.sigmoid, model_output. Now, we will find the accuracy of the model based on the predictions performed with respect to the actual data, and it is written as accuracy equals tf.reduce.mean, predictions_correct, and the residual losses are estimated by residuals equals model_output minus y_target. Next, in order to utilize the variables you have created, you need to initialize the variables. To initialize all the variables in one go, call tf.global_variables_initializer, assigned to the object init, which needs to be started by using ses.run init. Next, you need to create the interactive scalars and histograms that are accessible in the Tensor Board. It is a device where you could monitor or visualize the predicted results and the estimates of accuracy and error rates. In order to access histogram and scalars in the Tensor Board, a summary needs to be generated. So, for that I am taking all the summary functions and data using summary_op equals tf.summary.merge_all. Now we need to feed the data into the train and test set utilizing the placeholders, and the initialized variables are utilized to perform logarithmic computations on the built model. So initially, create three lists named as loss_vec, train_ac, test_ac. These are utilized in the computations to append the results generated from the loss and predicted functions, and further utilized for plotting the graphs. As you can see, a for loop is created providing the iteration range as 1500, and the new objects are created to access the feeding data with respect to the batch size by name rand_index, rand_x and rand_y. All the functions are called inside the loop, such as loss function, prediction, residual loss, and summary function of histogram and scalars, and provided the train and test data is fed for the computation by the running the session using ses.run. For every iteration as record will insert it from the train and test data, and all the logarithmic computations are performed and results are appended into loss_vec, train_ac, test_ac. For every iteration, the results obtained from variables a, b, loss, train accuracy, test accuracy are displayed in the output console. All the obtained results are stored in the event file, which is accessed by the Tensor Board for developing the computational graphs, and it is done by calling the function as writer equals tf.summary.filewriter, folder location, ses.graph. This event file is stored in a physical location by creating a temp folder in the local C drive, within which a folder by name event_logs. Now run the code and you can see the output results as displayed in the console, where the variables slope and intercept values a, b is estimated and loss values are generated for each iteration. You can also see the train and test accuracy values in the console. Now, with the generated results, entropy loss per generation graph and logistic regression graph is plotted. You can visualize the graph in the console for the loss generation for each iteration, where the loss is gradually decreased as per the gradient descent optimizer. You can also visualize the accuracy rate of training set and testing set in the console. Finally, to display this results in Tensor Board, open command prompt and run the command as Tensor Board log dir c:\temp/tensor logs/event_logs port 6060. A portal address is generated to access Tensor Board, which access the event files that are generated in the given file location, and it is shown as E123PC:6060. Open the web browser, and access the portal, and you can find the Tensor Board with all dashboards. You can monitor the accuracy rate of the interactive scalars, where the accuracy has got gradually increased and the estimated accuracy of the model is 63%. With further improvements and modifications in the data, the accuracy can be improvised. Now you can see the computational graphs where you can monitor all the operation nodes with respect to the variables and mathematical functions developed for computations. You can also monitor the error rate and residual losses in distributions and also in the histograms, which shows the gradual increase or decrease of the error levels. This completed the step-by-step procedure of building the logistic regression model using TensorFlow. That's all for this video. For any queries, please reach us at vj.reddy@sangam.ai.